Okay, so we're going to look at this problem here, and in this problem we want to determine the reactions at point A and point B on this beam. Now, we want to start with a free body diagram. Okay, free body diagram's right here. Okay, I'm going to include the 600, 800, and 900, the forces and the moments, those external forces, and then I have support reactions. First, looking over at point A. A is a pin. I think about how it's restricted. I'm not allowed to move this beam horizontally, nor am I allowed to move it vertically. The pin is restricting motion both in the horizontal and vertical direction. That's why I have AY and AX down here. And again, you can assume any direction you want. If you assume incorrectly, you simply get a negative answer in the results. Now, at point B, I recognize that this member right here is a two-force member, right? I've got force at B and a pin at C, so forces at B and C, just two locations on this member. Okay, meaning that the force has to be equal, opposite, and collinear. That means the force is got to be directed along the line of B to C, okay, which actually is a 3, 4, 5 triangle, or a 1.5, 2, 2.5 triangle. So I know that that force is in that direction, so I draw that in there. Again, if I have it pushing up, it might be pulling on it. I'll just get a negative answer if I'm wrong. But recognizing that this is a two-force member, therefore the force is directed between those 2 points is important in drawing my free body diagram. And that takes care of all of the moments and forces. Now I'm actually going to start with my moment equilibrium equation, right? I have 3 equilibrium equations, some of the forces in the x and y, and then the sum of the moments. I'm actually going to sum the moments about point A, and the reason I'm going to sum them, because I can choose any point to sum the moments about. The reason I'm going to choose point A is because I have both AX and AY at that point. So when summing the moments of all of these forces and this couple moment, okay, the moment of AX and AY are 0, so they do not show up in the equation. The only unknown that's going to show up in this equation, the only force about point A, the only unknown force about point A is going to be FBC, because these two pass right through. They have 0 moment about point A. Okay, so FBC, the horizontal component, goes right through point A. So I'm really only concerned about the vertical component, which is 3/5 FBC, and that's at a distance 2 meters away. So I get 2 3/5 FBC. That's the moment of this force about point A. Again, AX and AY have no moment. Okay. Then I have 600 1 meter away, and that's actually creating a negative moment, a clockwise moment. I have 800 4 meters away, creating a negative moment. Okay, so those are all of my forces. Okay, the moments of all the forces. I also have this 900 Newton meter couple moment, and it's a negative couple moment. It's a clockwise couple moment. Now, the location of that's not interested, so you'll note, or not important, excuse me. So you'll note that I don't multiply that times any distance, right? That couple moment is a free vector. It acts basically everywhere on the beam. So I just throw that in there, minus 900. The location's not important. I don't multiply times 4 or anything like that. I just put in 900. As opposed to the forces, which their location is important. I'm taking 800 newtons times 4 meters, or 600 times 1 meter, or 3/5 FBC times 2 meters. Okay, so this is my moment equation, and now summing the moments about A, again, the only unknown is FBC here. The AX and AY do not show up. So I can solve for FBC, and I find that it's 3.92 kilonewtons, or 3,916 or 17 newtons. Okay, so choosing that point to take the moment about being A, I can directly solve for FBC. Now I'm left with 2 unknowns, AX and AY, that I will put into some of the forces in the X and the sum of the forces in the Y direction. So in the X directions, I have the 4/5 FBC, the horizontal component. So this is FBC, which I just solved, 4/5. and minus AX, AX being the only other force in the x direction. So I can directly solve AX from that equation. My y direction, I have minus AY, minus 600, minus 800, and then 3/5 FBC. Okay. Again, the couple moment's not going to show up anywhere in the force equations because it's not a force; it's a moment. Okay. So in the y direction, minus AY, minus 600, minus 800, plus 3/5 FBC. Again, the only unknown in this equation is AY. So I can solve these two equations directly. I find AX equal to 3.13 kilonewtons and AY equal to 950 kilonewtons. So again, draw your free body diagram, get all your support reactions in there, sum the forces in the x and y, set them equal to 0, sum the moments about any point, set that equal to 0. Get your answer.